Hello there and welcome to the series of videos that's going through the content of A-Level Maths. Here we're going to look at the two key trigonometric identities that we'll need for A-Level Maths. So what we do is we're going to start off with a diagram here and I can show you where these two identities come from. So what I'm going to do is I'm going to draw a triangle with a radius of 1. So therefore these sides, if we use the angle of theta inside here, labelling the triangle of O, A and H and using our formulas, for the sine one, if we want to find the length on this hypotenuse here, then it's going to be sine times the hypotenuse, that's 1 times sine of theta. So the opposite side here is sine theta. And for cos, the hypotenuse here is 1, and we blank out the adjacent, and we get cos on this side here. So in any triangle, inside a circle with radius 1, it's going to have a radius of 1, so that's effectively the hypotenuse of that right angled triangle. The height is going to be sine, and the adjacent side here is going to be cos. So we haven't seen our identities yet, so let's have a look at tan. Tan is equal to opposite over adjacent. So if we work out what tan of this angle here is, opposite is sine and adjacent is cos on the lengths of these sides here. So in this case here, tan is equal to sine, which is was our opposite side, and that's divided by cos, which was our adjacent side. So tan equals sine divided by cos. Another way of thinking it is tan of theta is equal to sine, which is opposite over hypotenuse, divided by cos, which is adjacent over hypotenuse, and you can times the top and bottom of both fractions by h, and you get O over A, which is exactly what you're looking for tan, opposite over adjacent. Okay, so this is your first identity. Tan is equal to sine over cos. So that's one of the identities you'll have to remember. What we're now going to look at is Pythagoras' theorem on this right angled triangle here. So what we do here is a squared plus b squared equals c squared. C is the hypotenuse, a and b are either of these sides. So in this case here it's going to be sine squared, which is a, add b squared, which is cos squared, which equals 1 squared, which is the hypotenuse squared. So in this case here, sine squared plus cos squared equals 1. So for both of these identities, that means no matter what angle we have, as long as it's the same angle in all three of these positions, or all two positions here, we get a value of 1, or in fact here, if we do sine of, say, 37 divided by cos of 37, then we'd get tan of 37. Okay, so you can substitute in for theta any angles that you want, as long as they are the same. Okay, so simplify this expression here. Sine squared 3 theta plus cos squared 3 theta. Well, given that our identity works here for any angle, as long as the two angles match up and are the same, then what we can simplify here this to is just the value 1. As long as the 3 theta and the 3 theta are the same in both positions, then that's fine. We can use our identity and say that that's equal to 1. Okay, what about this thing here? Simplify the following expression, 5 minus sine squared. Well, in this case here, what we can do is factorise, and we get two values of 5 here, so it's 5 bracket 1 minus cos squared. Now what we can do here is we can rearrange sine squared plus cos squared equals 1. And the reason it's got a triple equals to sign on here is because it's an identity. It always works no matter what value we use for theta. So we can subtract cos squared from both sides and we get sine squared equals 1 minus cos squared. So this is it's like a third identity that comes from the second one. And we can also subtract sine squared theta, which will give us cos squared theta equals 1 minus sine squared theta. So effectively, for one identity, you get 3 that you can use at any point inside a trig question. And in this trig question here, what I'm going to want to use is this value here, 1 minus sine squared theta, because this is exactly equal to cos squared theta. So what I've done here is I've simplified 1 minus sine squared theta to cos squared theta. Okay, so the next expression is a little bit more tricky here. Sine of 2 theta divided by 1 minus sine squared 2 theta. Well, just a reminder from what we did before, 1 minus sine squared theta equals cos squared theta. Now the fact that there's a 2 theta here and a 2 theta here doesn't matter as long as these two angles here are the same. So what we need to do here is replace 1 minus sine squared 2 theta with cos squared 2 theta. The square root of this is going to be cos 2 theta. Just a little reminder here, the square root of cos squared is equal to cos. When we say we square a cos expression here, it's effectively cos of theta squared. So cos squared theta is equal to cos theta squared. We don't square the angle, we square the value that we get once we do cos of theta. Okay, we haven't quite finished this yet. We've still got sine 2 theta over cos 2 theta, and now we can use the first identity that we worked with at the start of this video. Sine over cos is tan, and because it's a 2 theta, the tan is also going to need a 2 theta as well. So make sure your thetas always match up with each other. Right, okay, we're going to prove an identity now, and this is starting to get a little bit tricky. Cos to the 4 theta minus sine to the 4 theta divided by cos squared theta is identical to 1 minus tan squared theta. Now, you have to do this in the way that I'm going to set it out here and show you how to do it. You can't be timesing values from one side to the other in this expression here. What you have to do is start from one side and show that it's identical to another side. Do not transfer items from one side to another. So what we're going to do here is we're going to start with the left-hand side of our expression here, and we're going to simplify what we get here. Now what we're going to do here on the top of this numerator here is effectively a difference of two squares. It's a bit like x squared minus y squared, which is equal to x plus y, x minus y. Only here we've got powers of 4, so it's x to the power 4 minus y to the power 4 is x squared plus y squared, x squared minus y squared. So you get exactly the same thing here. Now, just a reminder that cos squared plus sine squared theta is going to equal 1, so we're effectively pulling in this identity from up here. So this is going to effectively cancel out or be 1 times cos squared minus sine squared. Now what we're going to do is split up that fraction, so it's now just cos squared over cos squared minus sine squared over cos squared. And simplify. Cos squared over cos squared is equal to 1. And sine squared over cos squared, it's a bit like sine theta over cos theta, only if we were to square the top and square the bottom will equal tan squared theta. And this is equal to the right hand side. So equals right hand side. So notice there how we haven't transferred anything from the left to right in our proof here. We've just continuously worked with our algebra until we've shown that the left hand side of this equation here, or identity here, is equal to the right hand side. Right, so what we can do as well is look at finding the values of theta when finding different values of sine, cos or tan, depending upon if theta is a reflex angle or not. So what we're given here is that cos theta is minus 3 over 5. Now ignore the negative for now, and effectively what we've got here is a ratio between the two sides. Cos theta equals adjacent over hypotenuse. So we know the ratio between the adjacent and the hypotenuse is 3 to 5. So it's 3 on the adjacent and 5 on the hypotenuse here. Now from a little bit of right angle triangle Pythagoras knowledge here, we know that the third side must be a 4 here. So therefore, sine theta equals opposite over hypotenuse must equal, opposite will be over here, hypotenuse will be up here, so it's 4/5. However, what we know here is that cos theta is a negative value. So, having a look at the sine graph here, for when theta needs to be a reflex angle. Now, just a reminder, a reflex angle is in between the values of 180 to 270 here. So given that cos on the cos graph here was minus 3/5 at this point here, when theta is a reflex angle, the sine graph here is also going to be negative in between 180 to 270. So in this case here, our final answer here is going to be sine theta equals minus 4/5. Let's have a go at another one of those, because that was pretty tricky. Given that sine 2 theta is 2/5 and theta is obtuse this time, find the value of cos theta. So, writing onto a right angled triangle 2/5 for opposite over hypotenuse. The third side here is obviously going to be root of 21. So the next thing we need to do is therefore find the cos angle. So this is going to be root 21 adjacent over hypotenuse. And for the sine, cos and tan values, when it's an obtuse angle, it's going to be in between the values of 90 and 180. Now when sine of 2 theta gave us 2/5, the sine graph was up here in the positive area, 2/5. But in this case here for the cos graph, when it's in between 90 and 180, we're going to get negative 21/5 here. So the answer here, cos theta equals minus root 21/5 when theta is an obtuse angle. Another question here involving trigonometric identities here is given that P equals 3 cos theta and Q equals 2 sine theta, show this. So what we're going to do here is we're going to start off by rearranging our two equations to get sine equals and cos equals, and then apply the identity of sine squared plus cos squared equals 1. So in the first case here, it's going to be q over 2 squared add p over 3 squared equals 1. And then times through by 36, the common denominator between 4 and 9. And we're going to get 9q squared plus 4, sorry, that should be a p here, 9q squared plus 4p squared equals 36. Right, okay, 2 sheets of questions for you to have a go at now, because these questions are important that we get these right. For the first couple of questions, pause the video and have a go at these questions. Right, okay, well done for pausing the video and having a go at these questions then. So given that 2 sine theta equals 3 cos theta, find the value of tan theta. Well, first of all, what we're going to have to do is a little bit of rearranging. And the first thing that came to mind with this question here is that we have sine and cos, but they want us to find tan. So what I'm thinking here is we use that sine divided by cos equals tan. So what I'm going to do from this line to the next is divide through by cos. So I get 2 sine theta divided by cos theta equals 3. Now I want to get rid of this 2 as well here. So I'll divide through by 2, because that's being multiplied onto the sine. And now I've got sine over cos equals 1.5. So now tan theta, because sine divided by cos equals tan, must equal 1.5. So now what I need to do is grab my calculator and type in tan minus 1 of 1.5, and I get theta equals 56.3 degrees. So the value of tan theta, whoops, I didn't need to do this bit, did I? The value of tan theta is 1.5. So the answer here is 1.5. Okay, for question 4b then, express tan squared theta in terms of sine theta only. So what we're going to need to do here is apply our identities here of sine over cos equals tan. and also sine squared theta plus cos squared theta equals 1. Now tan squared theta here is effectively sine squared theta over cos squared theta. Okay, so that's kind of good. We're nearly there. We want to express it in terms of sine only, so we're going to need to change this cos squared into sine squared. Now, how do we do this? Well, from our identity, we just want to leave the cos squared where it is. So if I take away sine squared from both sides, I'm going to get cos squared theta equals 1 minus sine squared theta. Okay, so what I get on the bottom of my denominator here is 1 minus sine squared theta. And this is my final answer here. So tan squared theta is identical to sine squared theta divided by 1 minus sine squared theta. Okay, another couple of questions here. Pause the video and have a go at these questions. Right, okay, thanks very much for having a go at these questions here. Now this one here is an identities question here, where we have to prove that either the left-hand side is equal to the right-hand side or vice versa. And we're not allowed to add or move things from one side to another. Now generally the way I would approach this is by choosing the most difficult looking side and then simplifying that side. Just from thinking this through in my head, I'm going to use this side first because what I'm going to end up with here is two trig expressions here, whereas I can simplify it to one here. There would be obviously a method of going from this side to this side here, but I'm going to go from this side to this side. So, starting with the right-hand side, which is equal to sine theta cos theta. So sine theta tan theta. First thing I'll do is I think I'll transform my tan theta into a sine divided by cos. So on the top here it's going to now be sine squared theta over cos theta. So I'll have sine times sine. Then I remember that sine squared can also be written as 1 minus cos squared over cos. Okay, so I'm basically nearly there. I've transformed a sine and a cos into just coses. So now I just need to split this up. So 1 over cos theta minus cos squared theta over cos theta. And I'm nearly there. So the final answer here is going to be 1 over cos theta. Cancel out one of the coses from the top and the bottom. So 1 minus cos theta minus cos theta. It is exactly what we have on the left-hand side. So this is as required. Okay, so when you're proving a trigonometric identity, just work on one side and show that it is identically equal to the other side. Okay, the next question here is that find the value of sine theta and cos theta given that cos of theta equals minus 3 over 5 and theta is obtuse. Well, that's silly. Let's just find the value of sine theta here. So let's just draw the graphs out to start with because I know they're going to be useful. The cos graph is going to look something like this. Cos, where this is 90 degree here, 180 degree here. So an obtuse angle is one from here to here. So the sine graph in between here and here is going to look like this. So we have the 180 angle here, we have the 90 angle here, and what we have here is cos theta equals minus 3 over 5. And that kind of makes sense because minus 3 over 5 will be in that position there. So on a right angled triangle, if I've got my angle here, it's going to be hypotenuse of 5 and adjacent side of 3. So this side over here must be 4. So sine of theta equals 4 over 5. But in between theta, between 90 and 180, the sine curve is positive. so I don't need to negate my answer here. So the final answer here, find the sine value when cos of theta equals minus 3 over 5, theta is obtuse, is sine theta is equal to 4 over 5. Right, this exercise is a really important exercise for mastering these trig equations. It's going to appear in your upper 6th year as well, so make sure you have loads and loads of practice now and have a go at lots of the questions from exercise 10C. Make sure that you can do it until you've mastered it, not just until you've had a go at 1 or 2 and got half of it right. Make sure you persevere through the difficult ones and ask your teacher for help if you need any. Right, thanks for watching.